The fourth learning objective in section 6.2 is to describe both the strength and direction of the linear relationship between two quantitative variables using the linear correlation coefficient. Match the linear correlation coefficient to the scatter plot. There are four scatter plots shown here. Now, all of them have a downward trend, but you can see that this first scatter plot has all the points exactly on the line. Scatter plot 2 has the points very close to the line. Scatter plot 3 has the points pretty far away from the line. And scatter plot 4 has the points again close to the line, but not as close as 2, and certainly not as close as 1. If we look at these values for the correlation coefficient, we have an R of negative 0.852, an R of negative 0.049, an R of negative 1, and an R of negative 0.969. The closer R is to either negative 1 or 1, the stronger the relationship. If R is equal to negative 1, that means there is a perfect negative relationship, meaning that there's a downward slope to the line and every point falls on the line. If R equals positive 1, then there's a perfect positive relationship. Now we know that all of these R values are negative, as all of our scatter plots indicate, because there's a downward trend. Positive R values would have an upward trend in the scatter plots. So we can first identify scatter plot 1, which has a perfect negative relationship, as an R value of negative 1. Next, let's look at scatter plot 2. This is the next strongest relationship, so it'll be the value that is next closest to negative 1. That's part 4 here. The third scatter plot has a pretty weak relationship. It's looking more like a horizontal cloud than really a linear relationship. So that's going to be an R close to 0, which is an R of negative 0.049. And then finally, the fourth scatter plot has a downward trend, but it's has a little bit more scatter in the points, and so that value will be not as close to negative 1, so an R of perhaps negative 0.852.